So this is lesson 71 in Algebra 2, the quadratic formula. Now what we've done in the past is given a quadratic equation such as x squared plus 2x minus 15 equals 0. You learned how to factor this into two binomials. Remember that? X and find two numbers multiplied give you 15, added give you 2. So that ends up being a positive 5 and a negative 2. Okay, so you factored it down there, and then you found out that x is equal either negative 5 from this one or 2 from this one. Because what we're looking for is what number can I put in here for x that's going to make this 0 so that when I multiply it times whatever this is, I'm going to get 0. And that's negative 5. Negative 5 plus 5 is 0. So 0 times anything is 0. Then I look here and say, alright, what number can I put in here to subtract 2 from and get 0? And the answer is 2. 2 minus 2 is 0. That times whatever this is, we don't care, is going to give you 0. Okay, so that's one of the things that we learned. Then we realized that there were some equations that you couldn't factor nice and sweet like this, and it took a little bit more effort. So when we had an equation like x squared plus 3x minus 3 equals 0, there are not two numbers that we can multiply to get 3 and add and get 3. Okay, so we had to change the way we did these. And what we did is we learned how to do what was called completing the square. And that was where you took x squared plus 3x, brought the 3 over here, took half of that and squared it, and put it right there, and put it right there. Okay, remember doing that? Okay. And then we made a parenthesis with a squared, and we took the square root of that, square root of that, this sign, and that equals this added together, which would be 12 fourths would be our 3. And that gave me 21 over 4, so I can just erase this and put 21 over 4 there. Then remember we took the square root of both sides to get rid of this squared, and we have x plus 3 halves equals plus or minus square root of 21, and the square root of 4 is 2. Whoops, this is an equal sign, sorry. Okay, then we subtracted that from both sides. And we got that for an answer. Okay, and life was good back then. But one of the problems with this whole completing the square thing is it's kind of a pain in the neck to use. Now, you will need it if you go on to college algebra. You will need it if you go into trigonometry. You will need it. So don't forget completing the square, but there is another way to do that, and it's called the quadratic formula. Now, what we're going to do is we are going to take an equation, ax squared plus bx plus c equals 0. That's a quadratic equation, just like, for example, x squared plus 3x minus 3 equals 0 is that we just did. Alright, the only difference is I don't know what the numbers are. Here, here, and here. A, B, and C are numbers. We don't know what they are. Okay, so let's pretend like we're going to complete the square with this. Alright, so first of all, when we complete the square, remember we can't complete the square when we have a number there. So we have to divide each of these terms by a in order to get rid of that one. So now we have x squared plus bx over a plus c over a equals 0. Okay. Now we're going to keep going. X squared plus bx over a, and we're going to move this to the other side of the equal sign. Okay, just like we do when we're completing the square. And And remember what we do with this? We take half of it and square it. So we take b over a, we take half of it. Remember when you take half of something, you double the denominator. How do I double an a? I put a 2 there. I multiply it by 2 and it's doubled, and then I square it. So now I have plus b squared over, square the bottom, 4a squared. Remember I have to do the same thing over here. Alright, so far I haven't done anything weird. I'm just following the rules for completing the square. The only thing is I don't have any numbers. I'm just doing it with letters. Alright, then I make a parenthesis with a squared, square root of that, square root of that. That sign there goes there. Okay. Next thing I need to do is find common denominators for that so that I can combine those. So let's move everything up here. So right now we are at this point. Looks kind of messy. So we'll do x plus b over 2a quantity squared equals. Alright, I'm going to use 4a squared as my denominator. I've got 1a there, so I only need 1. So that's going to be negative 4a over 4a squared. Because see what I did? I just kind of did it in my head. Oops, forgot the c. Sorry about that. I looked here and said, what am I missing here that I have here? Well, I've got an a, so I only need 1a, and I'm missing a 4. So I took a 4 and an a and put it over here. So the a that I was missing and this a gives me a squared, and that's ac. And then over here, nothing changed because I wasn't missing anything here. So now I've got x plus b over 2a. I'm going to put this all together. Okay, and I've got that. Alright, let's move stuff up again. Whoops, just move stuff up. Don't erase stuff. Okay, why is that c all by itself? Okay, now square root of both sides. And I get x plus b over 2a equals plus or minus square root of, we'll put the b squared first, over, in fact let's do this, I know we can find the, it's really all over, including the denominator, but let's take the square root of that so we don't even need the square root on the bottom. We just make it 2a. Now let's solve for x. X equals negative b over 2a plus or minus square root b squared minus 4ac over 2a. And lo and behold, our denominators are the same. So we can come up with this as our final answer. So we just found x. Look at that mess. This problem right there, or this formula right there, is called the quadratic formula. I would memorize that. Makes it a lot easier. For when you need to do this, you're not looking back. I'd also write it at the top of the page when you're doing this so you remember it, so you don't make any mistakes. So there's our formula. So let's see what we can do with that formula. Okay, let's erase everything here. Okay, there's our formula. Alright, so let's say that we have that equation there, and we're trying to solve it. This is our A, this is our B, that's our C. So wherever we see an A, B, and a C, we plug in 3, negative 2, and 5. So let's do that. Negative B, negative, and what is B? Negative 2. b squared. A is 3, c is 5. All over 2 times whatever a is. Okay, so let's simplify it. This is a positive 2 plus or minus the square root of negative 2 squared is 4 minus 12 times 5 is 60 all over 6. Okay, so we're slowly but surely simplifying this thing. Okay, let's get that up there. Okay, now we've got 2 plus or minus negative 56 over 6. Okay, we're getting closer. This is really 2 over 6 plus or minus the square root of negative 56 over 6. So see how I split the 6 to go with the 2 and then to go with the 56. Alright, and then that can be, let's see if I can move this chunk up, 1/3. 2 6 reduces to 1/3 plus or minus, and the square root of negative 56. Remember, whenever you have a negative in there, you pull out an I. Okay? And we're going to continue a little bit more because the square root of 56, I wonder if that can be reduced. Square root of 56, what is that? That is a 14 times 4, right? And I can take the square root of 4 and move that out here. Okay, see what I did there? I just took the square root of 4 and pulled it out. Then I can reduce 2 over 6 to 1 over 3. So now I have 1/3 plus or minus square root of 14 over 3i. Oh goodness, that's a hard one, isn't it? Alright, let's do one more, and we'll do that on the next video.